What I'm showing here is how to use this Saturn Visual Analytics tool to explore some security data events to find some patterns or anomalies that would be useful for further investigation. First, let's assume I'm an analyst of customer A, so therefore I can only see and do analysis on my own data. In this case, the data is about the malware events that have been detected inside customer A's network. Here we see an example layout of the workbench with a number of different gadget windows. First, here we got the pie chart gadget. In this case, it shows the relative frequency of the operating system of the infected machines. We see here most of them are running Windows XP. Then we got the bubble map gadget. This shows the relative frequencies of the malware found on the machines, indicated by the size of the bubble or circle. Here we see the G2135 malware has the highest frequencies, followed by Easter and 1700 and so forth. In total, there are 6 different malware found in this dataset. Next, we got the network gadget to show the links between the selected event attributes as source and destination. Let's maximize the window. Source is red, here indicating the malware name, and the destination is green. In this case, is the IP address of the infected machines. Here we can see that this group of IP addresses or machines are infected by 2 or more malware. Finally, here we got the map showing the geolocation of the infected machines. In this case, in India region. Here shown as dots. The size and color of the dots show the density of the events. All these gadgets are linked together, which is useful for doing the analysis when filtering the data. For example, I can start looking at only infected machines running on Windows 7. Now it will change directly the bubble, network, and map gadgets. Furthermore, I can also filter this area in network gadget to isolate this group of IP address that I might want to investigate further and cross-check with other datasets that I have. This is the kind of analytics that the customer can perform on their own data. But basically, the insight that they got is limited to their own data. They don't get the bigger picture. They don't know whether they are the only ones or the first affected by the malware. This applies to each customer. Each customer may get different insights from their own data. Here, customer B, based in Japan, affected by 3 malware. Then we have customer C, based in China, affected by 5 malware. Our vision in SIPS is to allow multiple customers or organizations share their cyber data with each other, but at the same time, they can still protect some confidential data and preserve their privacy. For example, by removing some sensitive attributes or anonymizing them. At the same time, they can still perform useful analytics on the aggregated data that have been sanitized or anonymized to preserve the privacy. This process should be seamless and automated. Now we merge all the data together. What already happened here to preserve the privacy are removing the identity of the customers, removing the IP address, and finally anonymizing the geolocation of the infected machines using differential privacy method. Here we can still recognize on the heat map the region where most of the infections were reported without revealing the exact geolocation of each infected machine. And we can also analyze which countries are most affected by these 2 malwares. This kind of collaborative analytics on sanitized dataset is currently being implemented in the SIFS project.